I made this snowman with a single inequality by using a combination of minimum and maximum functions. In this video, I'll show you why that works, and by the end, you should be able to make whatever you want in one inequality like this. This is the minimum function. It takes two or more numbers and outputs whichever one is smallest. So why would picking the smallest number be able to combine shapes like two circles into a snowman? The answer is that we can use equations and inequalities to ask a simple question. Does this point belong? Let's take the top circle of our snowman first. It has a radius of 1 and is centered at the origin. We can describe it with an equation you've probably seen before in high school. X squared plus y squared equals 1. To include the inside as well, we can write it as the inequality x squared plus y squared is less than or equal to 1. Now, I'm going to subtract 1 from both sides to get x squared plus y squared minus 1 is less than or equal to 0. Why did I do that? Well, it makes it a little easier to work with later on if we use 0 on the right side of our inequality every time. We can think of the left side of our inequality as a function of x and y. We get different outputs based on what values of x and y we input. On the graph, let's look at different xy coordinates. Watch as the number changes as we move the point. Every positive output doesn't satisfy our inequality. Every negative output does, or 0. So our graph is the same as asking, is our function negative or 0 here? And then doing that for an infinite amount of points. Let's draw the bottom circle now. We can shift it down and increase the radius like this. We can ask the same question about the points in this circle too. Is our function negative or 0? Yes? Plot that point. No? Don't plot the point. Now we have two shapes, and we can ask two yes or no questions about our point. Are you inside the bottom circle? Are you inside the top circle? And depending on where the point is, there are exactly 4 possible pairs of answers. Instead of yes or no, I'm writing T or F as true and false, because in mathematics, we use truth tables to understand logic. Now that we've set up our truth table, we can start to look at what are called logical operators. The ones we'll look at are known in common parlance as and, or, and not. To make our snowman shape, we'll start with or. A point belongs inside the snowman if it's in the bottom circle, or the top circle, or both. Take a look at the truth table that shows this. Now, let's go back to our circle functions. Recall that for each shape, true means the output of our function is negative or 0, and false means the output is positive. For or, we need at least one of our two numbers to be negative or 0. You can see that whenever our point is inside our two circles, one or both of them is negative. In other words, as long as one of them is negative, it doesn't matter what the other one is doing. Another way of saying this is that we only care if the smaller number is negative. We can ignore the bigger one, because if the bigger one's negative or positive, who cares? So taking the minimum of our two outputs gives us the exact same truth table as we had before. So min, or minimum, is equivalent to or. Let's ask about in both circles at the same time. That's and. Here's the truth table for it. For and, both outputs need to be negative or 0. That means the number to watch is the bigger one. If the bigger one is greater than 0, we don't care about the smaller one anymore. So this time we want the larger of the two numbers, max or the maximum. Max is equivalent to and. You can see the exact same truth table here. Okay, we've got or and. There's one more piece of logic we need to let us create whatever shapes we want. Not. Not in the top circle just means flipping the sign of our function. This works because when we flip the sign, we're essentially flipping the inequality sign. Now combine that with and in the bottom circle and not in the top circle. We can use this idea a few more times to carve eyes and a smile out of the snowman's face. While we're at it, let's add some arms and even a hat, which we can use with minimum. So now, what are you going to make? If you make something cool, leave a comment with the code that comes after your desmos.com/calculator so we can all see your work. I hope you enjoyed watching and will consider subscribing And let me know if you'd like a separate video about how I made the hat or the arms and how I make different shapes with these functions.